Greetings, Spartan fans. Today we are going to talk about properties of logarithms and expanding and condensing and using that to help us solve. Okay, so the gold sheet, it's on gold paper, properties of logs, because it is important and I want you to be able to easily access it when you are looking in your notebook. The log base b of b is 0. Not true. The log base b of b is 1. The log base b of 1 is 0. Okay, power rule says that if you have an exponent, you bring it down in front and you make it a coefficient. So the log base b of m to the n is n times the log base b of n. Product rule says that if you multiply arguments, okay, this is an argument. Multiply arguments, you are going to add the logs. So this becomes the log base b of m plus the log base b of n. Quotient rule, divide arguments, subtract logs. So this is going to become the log base b of m minus the log base b of n. Change of base. You want to convert this to a base of 10. It is the log of the argument divided by the log of the base. This property is totally cool. You have the base of the log, which is b, and then you have the base of the exponent, which is the log. Looks really funky, but the log base b of b to the log base b of a is a. So for example, if this was 6 to the log base 6 of, how about 7, the answer to this would just be 7. Logarithmic functions with a base of e are called natural logs. So the log base e of x is abbreviated as the ln of e. Okay, so we're going to expand, we're going to contract, we're going to use all these properties. Okay, so expand, that means I'm going to have multiple logs. We're going to use a sum or a difference. We're going to have multiple logs. Okay, so right here, this is my argument. So I'm going to separate x minus 1 times x plus 2 squared. I'm going to separate that into the log base 3 of x minus 1 plus the log base 3 of x plus 2 squared. The argument was being multiplied, so I separated it using addition. And then I'm going to bring the 2 down in front. So this 2 is going to go down in front. And now you have expanded it into the sum or difference of logs. Okay, this next one's pretty complicated. First thing I'm going to do is I'm going to start with the fact that there is a division. When you divide arguments, you subtract the logs. Divide arguments, subtract logs. So I'm going to start with the log base 5 of x squared y cubed minus the log base 5 of the square root of z. That's where I'm going to start. Okay. Now my argument here, that's x squared times y cubed. Multiply arguments, add logs. So this becomes the log base 5 of x squared plus the log base 5 of y cubed. And I'm going to rewrite the square root of z as z to the 1/2 power. Roots are fraction exponents. And now I'm going to use the power property. I'm going to bring the 2 in front. So it's 2 times the log base 5 of x plus 3 times the log base 5 of y minus 1/2 times the log base 5 of z. Exponents come down in front and become coefficients. Okay, that 2 should be part of the answer. Okay, now I'm going to go the other way around. So now I've got 2 logs. When you add logs, you multiply arguments. So this is going to become the log base 2 of one of the arguments is x, the other argument is x minus 3, 1 log. And if you want to distribute the x, you can, but it's not necessary. Okay, this next one, ln. ln is the same thing as the natural log. Okay, so remember, ln is a base of e. Okay, so when you add logs, first thing you should get used to doing is bringing the coefficients up and making them exponents. So this is going to become the ln of x minus 2 plus the ln of x to the 1/2. And I'm going to leave it as subtraction for right now, and I'm just going to bring up the 5. Okay, so now I have the ln of x minus 2. And then when you add logs, so I'm adding the logs, I'm going to take one of the arguments, which is x minus 2, and I'm going to multiply it by x to the 1/2. Okay, well, x to the 1/2 is the square root of x. Okay, and now when you subtract logs, you divide arguments. You don't divide the logs. So this is going to become the natural log of, I'm going to write a big parenthesis, x minus 2 times the square root of x over x plus 3 to the 5th. A lot of parentheses. And that is a singular log. Okay. All right, so we're going to solve log equations algebraically. The strategy. So I'm going to give it all to you here in a summation. So rewrite the equation using properties of log so that it is written one of the following ways. You want it to have the log base b is equal to a constant. Constant is just a number. Or the log base b of some number is equal to the log base b of another number. If the equation is in the first form, change it to exponential form. If the equation is in the second form, so if it's in this form where you have some log, the log of some number equals to the log of another number. Okay, so we're going to use the property that says if the log base b of m is equal to the log base b of m, then n equals n. And don't forget to check your solutions. So remember that the domain of a log is that the argument x must be greater than 0. Okay, so now we're going to solve some equations. Okay, so the first one, we have the log base 2 of x minus plus 2 plus the log base 2 of 1 minus x is equal to 1. So first thing I have to do is condense this into one log. When you add logs, you multiply the arguments. So this is going to become the log base 2 of x plus 2 times 1 minus x, and that equals 1. And now I'm going to change forms. It's in log form, change it to exponential form. So the base is 2, the exponent becomes 1, x plus 2 times 1 minus x. Multiply, set it equal to 0, use the zero product property. Factor uses zero product property. So you're going to get 2 equals negative x squared plus x plus 2 minus 2x. I'm going to set this equal to 0, so I'm going to add x squared to both sides. I'm going to add x to both sides, and I'm going to subtract 2. So I moved the negative x squared to the left so I could keep it positive. X minus 2x is negative x. I moved it over, and then 2 minus 2 is 0. And now I'm going to take out the GCF. So you get x equals 0 or -1. Okay, the next one, again, combine it so that it's one log. So I've got x minus 1 and x for my arguments. So I'm going to combine that. So this is going to be the natural log of x minus 1 times x, and that's going to equal the natural log of x plus 2. And now you have equal base, equal arguments. So I've got an argument of x minus 1 times x on the left and an argument of x plus 2 on the right. So this is going to be x minus 1 times x, equal base, equal arguments. So this is x squared minus x equals x plus 2. Set it equal to 0. Subtract x, subtract 2. Okay, and then from here, I believe we're going to have to use the quadratic formula. Don't forget, always simplify radicals. And then reduce. Okay, and then you got to be careful here because 1 plus the square root of 3 is a positive number. 1 plus the square root of 3, I don't know what that is, but this is positive. But 1 minus the square root of 3, that's a negative number. And if you were to plug this back in and check, remember the domain of a log is the argument has to be greater than 0. I hate when that happens. Let's try this again. So if you were to plug in the natural log of x, if you were to plug in right here for x, you would get a negative. So 1 minus the square root of 3 cannot work. The answer is simply 1 plus the square root of 3. And that's the answer. Okay, so this next one's funky because I've got a log on the left, I've got a log on the right, but then I have this one that doesn't have a log at all. So what I'm going to do here is I'm going to combine the logs on one side. So I'm going to move the log of 1 plus c to the other side by subtracting. So this is the log of 1 minus c minus the log of 1 plus c, and that's going to equal to 1. And now I'm going to use the properties that say when you subtract logs, you divide arguments. So this is going to be the log of 1 minus c over 1 plus c equals 1. And now I have a log equal to a constant. So now I'm going to change forms. And don't forget the base is 10. So this is going to become 10 to the first equals 1 minus c over 1 plus c. It's the same thing as 10 over 1, and now I'm going to cross multiply. So I'm going to get 10 times 1 plus c equals 1 minus c. Subtract 10, you get -9. It's possible to have a negative answer. You don't know that until you go back and you plug in. So when you check this answer is okay. Because if you plug in -9/11 right here, you get 1 minus -9/11, that's positive. If you plug in -9/11 here, 1 plus -9/11 is a positive number. If you don't believe me, you can check on a calculator. So you can have a negative answer. What you can't have is a negative argument. Okay, last one. So again, I'm going to use my properties of logs. So I'm going to combine on the left. And this is going to be, oh, wait a second. This has a base of 7. This log has a base of 8, and this log has a base of 8. But the log base 7 of 49 can be simplified. The log base 7 of 49, so I'm going to pull this out. I'm just going to look at it separately. The log base 7 of 49, set it equal to x. X is 2. So the log base 7 of 49 simplifies to 2. So this becomes 2 plus the log base 8 of x equals the log base 8 of x minus 1. And now I'm going to do what I did in the previous problem. I've got a log on the left, a log on the right, but then I got this pesky 2. So I'm going to move the log base 8 of x to the other side by subtracting. So I'm going to get 2 equals the log base 8 of x minus 1 minus the log base 8 of x. When you subtract logs, you divide arguments. That should have an 8. And now I have a log equal to a number. I'm going to change forms. Okay, so this is going to become 8 squared equals x minus 1 over x. 8 squared is 64. Again, cross multiply. So I get 64x equals x minus 1. Subtract x from both sides. X is negative 1 over 63. But if you check this, negative 1 over 63, if you plug back in and you check, let me use a different color. Negative argument. You must check your work. So x can't be negative 1 over 63. The result to this problem is no solution. And that is properties of logs and solving log equations.